video, we will talk a lot about system of linear inequalities. Okay, before we go to the system of linear inequalities, let's learn what is linear inequality. Okay, so since we are talking about linear, so let's start with linear equation first, and then we convert that into inequality, and then we can learn what is the impact to the graph itself and to the solution. Okay, let's say that we are having one of these equation. Okay, this is linear equation, and this is in slope-intercept form. Slope-intercept form, why? Because from here we can find that the y-intercept is -4 and the slope is -3/5. Okay, so like if we have to show the solution, it is a graph, okay, which is linear, okay, a line, and this line presents all pairs, all ordered pairs with that satisfy this equation. Okay, but let's convert this into an inequality. For example, if we convert that into y greater and equals to -3/5x minus 4. Okay, so the solution, since it is greater and equals to, the solution will be the ordered pairs that's shown on the line. Okay, but not just this, but all area above the line, above. Okay, so all ordered pairs that is inside of this blue area. Please keep in mind, because this is a straight line, a straight line will be a separator between two areas only, the above the line and below the line, only two areas. But we have to know which area that being presented or the solution of this inequality. So let's check it by just by using one of the coordinates that inside of this area, the blue one. Okay, for example, 0, comma 0. Okay, 0 for the x and 0 for the y, and you substitute it into this inequality. Will it be satisfied? So 0 here and 0 here. It becomes 0 greater and equals to -4, and it's true. It means you can be sure that all ordered pairs inside of this blue shaded area will satisfy this inequality. You don't believe it? Just try to use -2, comma 0 or 2, comma 0 or 2, comma 2 or an extreme pairs anywhere inside of this blue area. Please keep in mind that you can still extend into that direction, right? So because this is just not, it's just limited on the graph, it doesn't mean that, for example, 1 million, comma 1 million is not inside the blue area. It's still inside the blue area. Okay, so you can try. It will consistently satisfy this inequality. So, in other words, if you pick any pairs inside of this area below the straight line, for example, this one, negative 0, comma -5. This is 0, comma -5. So if you put -5 as your y and 0 to substitute your x, you will be certain that it won't satisfy this inequality. Just try it yourself. Okay. So without checking one by one, is there any quick way how to decide where is the area that's being the solution? So let's see to the inequality. So if we have a slope intercept form, okay, which is the on the left member is the y, and then on the right member is the x, and this the slope and the y intercept, it will be easy. If it is a greater, okay, with an equal sign or without an equal sign, as long it is greater, don't forget the y always present, the perspective is always the vertical one, right? The y is the vertical one. If it is greater, it means it is above. Great, up, above. Greater, it means the straight line and the area above it. So if there is an equal sign, it means the straight line is also be the solution. If there is no equal sign, so you only present the area above the straight line as the solution, but the straight line itself, it is not the solution. I will give you another example later. How about the inequality without the equal sign? But for this one, Since it is greater and equals to, again, shade the upper area or the area above the straight line and the straight line itself. It is the solution. And this is the second example. If I give you an equation, okay, still in slope-intercept form, and we have y equals 2x minus 1. Therefore, we know that the slope is 2 and the y-intercept is negative 1. Let's just graph it. And this is it. This is the solution, okay, of this equation. It means all pairs on the line, on the straight line, will satisfy this equation. But if I change it into an inequality, for example, lesser than. So without equal sign here, only y less than 2x minus 1. Okay, since this perspective is from the y less than, it means the area below the line, below the straight line will satisfy this inequality. So let's shade it below. Okay, so if this is the straight line, so let's just be careful in defining below and above. Okay, since this is the straight line, the above area will be this part and the below area will be this part. So I shaded the yellow one. It means all ordered pairs inside the yellow one will satisfy this inequality. But since there is no equal sign, it means all ordered pair on the straight line won't be the solution since there is no equal sign here. Okay, so only the ordered pairs are inside the yellow shaded area is the solution, but not the straight line itself. It means we need to put the dotted line instead of the solid one, since we have to show that the straight line itself is not the solution, only the shaded area. Okay, that is how you show it. Again, from here I can be certain that 5 comma 0 or 0 comma negative 4 or 3 comma negative 3 or 3 comma 2 will be the solution that will satisfy this inequality. You can check it. But 0 comma 0 will not satisfy. For example, let's just try 0 comma 0, 0 for your x and 0 for your y. The statement becomes 0 less than negative 1, which is, yeah, it's not true, right? It's false. Okay, so we can be certain all of the pairs inside of this area, okay, the area above the straight line and also the straight line itself won't satisfy this inequality. At this third example, I will explain you and introduce you about the system of linear inequalities. Before we go to the system of linear inequalities, let's recall back about the system of linear equations. Now, in this system, I present you two functions only. Okay, as you notice that these both functions have the same slope, which is 4/5. It means since they have different y-intercept, they will be parallel to each other. So let's graph these two functions. This is the first one, this is the second one. Okay, the y-intercept is 2 and the second y-intercept is negative 1. Since they are parallel to each other, we have an inconsistent case, right? Inconsistent equations. Since we have inconsistent equation, it means there will be no solution because they don't intersect each other. Okay, if we are talking about linear equations. So let's now change this into inequality. Let's start from the first one. For example, I will change it into greater than, only greater than. And the second one, I will change it into less than or equals to. Less than or equals to. Let's start with the first one. Since I changed into greater than, originally it is an equal sign, so it is just this straight line. But since I change it into greater than, it means the solution will be the area above the straight line. Greater than. Y is greater than. Above the area. So let's shade the area above the straight line. So it is this green one. So you can be sure that all the pairs inside of this green area, I mean, yeah, of course, we cannot limit it into this graph only. You can extend it into the left part and the right, and the upper area, it will be the solution. But the straight line itself will not be the solution, will not be included. So don't forget that you have to change it into a dotted line. Okay, so that is the solution of the first inequality. So how about the solution of the second inequality? Since it is less than or equals to, it means the straight line is still a solid line, since it is also the solution. But the area that being shaded less than, it means the area below the straight line. So let's shade it. So this is the yellow one. So this is the solution of the second inequality. And the solution of the system will be none. There will be no solution. Why? Because the solution of the system has to be the intersection, okay, of all of the areas between these two inequalities. Since the areas that being shaded is not intersecting each other, we have no solution. Let's get back to the original equations. Okay, since they are parallel to each other, if we are speaking about linear equations, the system of linear equations, there is no solution, right? Because there is no intersection. But if we are speaking about linear inequalities, it doesn't mean that they don't have solution. Okay, for example, if I change the first one into less than equals to, okay, the blue line, less than equals to, it means the one that I present as the solution will be the straight line itself and then the area below the line. So keep in mind, I won't shade it now. Okay, let's just keep in mind that the solution will be the straight line and the area below the line. And if I change the second function into an inequality of greater, okay, greater than, it means this line, this straight line, will be dotted first, of course, and then the area that's being the solution will be the area above the line. It means the intersection between the first one and the second one will be this area. So this is the solution of this inequality, the intersections of the area between two inequalities. So this will be the solution, and you have to shade it, and you have to keep in mind that it's not limited into until this area only. It's still extended into that direction and into that direction. So this is the solution of this inequality, since we have intersection between two areas of these two inequalities. It, compared to before we don't have the intersections between two areas. Let's see another example. If I change into this and this inequality, so the first one, the blue line, is less than equals to. It means it is still straight line, and also the coverage of the area will be the one that's below the line. So all the solutions will be the straight line and the area below the line. So that is the first inequality solution. And the second inequality solution will be the dotted line, of course, because we have no equal sign there, and the area below the line. Okay, keep in mind that the first one is below the straight line, the solid straight line, and the second one is below the dotted line. It means the intersections between two inequalities will be the yellow one. Okay, this will be the solutions of this system because the intersections between two areas of these two inequalities will be only the yellow one, and this one will be dotted. The last example for this section is if I change it into greater and equals to for the first one and greater only on the second line, on the second equation. So of course this one is still solid, okay, since it's greater and equals to solid, and you can keep in mind that the one that means the solutions is the area above the line, right, above the line. So this one. And for the second one, since it is greater only, so it will be dotted line, the second line, dotted line, and the area being shaded is also above the line. So what is the intersections between two areas? This one and this one, the intersection, will be the green one. Okay, so this is the solution of this inequalities system. In the last sections, let's learn about how to graph inequalities, a system of linear inequalities, if you're given in this kind of forms, the equations, ax plus by equals c, not the slope-intercept form. So before we go to the inequalities, let's go to graph the equations first. Okay, of course, the first option is you have to convert these ones into slope-intercept form. That is the first option. After you convert that, then you can graph it by using the slope and the y-intercept. But we have other method, right? If you recall back from this one, you can use the table of pairs, right? Use the table of pairs and find at least two pairs, and then you connect it with the line. For this one, I will use the x-intercept and y-intercept technique. So for the first equation, the x-intercept will be 2 and the y-intercept will be negative 2. The x-intercept will be 2 and the y-intercept will be negative 2. So this is the straight line of the first equation, the green one. And then the second one, using the y and x-intercept also, which is on the table of pairs, the x-intercept is 2 and the y-intercept is 3. So I can go directly graph it. So yes, this is much easier if you know this technique rather than you convert this one into the slope intercept form and then graph it. And then the last one, since we have another good situation to use that same technique, so the x-intercept is negative 1 and the y-intercept is 5. So this is the straight line. So this is how you graph quickly the ax plus by equals c form by using the table of pair or the x-intercept and y-intercept technique. Let's solve the system of linear inequalities involving these three inequalities, right? So let's just say if I give you example, the first inequalities is greater or equals to, the second one is greater or equals to, and the last one is less than or equals to. What is the solution of these three inequalities? Let's recall back previously, if we want to shade or we want to determine the solutions of each inequality, we use the slope-intercept form, which is easier for us since the statement is clear. It's y and then less or greater equals to. So in these examples, you have to be careful because we have ax plus by and c here. So it is different. So the first option is you convert each of these inequality into the slope-intercept form, and then you can determine whether the shaded part, the shaded area will be the above the line or below the straight line. But for this one, let's just make it a quick one, a quick method, how to shade the area from this form. Okay, so start from the last one. Okay, this negative 5x plus y less equals to 5. It means that you still need to see from the perspective of y, but keep in mind it must be positive y. Okay, so let's see this one, the y coefficient is positive, so it's good. Since the y is less than or equals to, it means the shaded part, the shaded area, the solution will be the area below the red line. So this is the red line. So the shaded one will be this area, not this one. Below. Okay, we have to differentiate below. This is below. This is above. Okay, let's go to the blue line. Since the y perspective is already positive, the coefficient, so let's go to the statement y is greater or equals to. It means if I go to the blue line, greater means above the line. So the shaded area will be above the blue lines. Okay, so keep in mind before the red line, it is on the right side. Okay, since it's below of the straight line, and then the blue line is above. Okay, and then the last one is this, the green one. The green one, be careful, the y actually is greater or equals to, but since the coefficient is negative of the y, you need to make the opposite. Okay, so again, the y is greater or equals to. Since it is negative, it means it's supposed to be y less than. So shade the area below the straight line. Okay, so the green line is below, the blue line is above, and the red line is below. So in the end, the intersection of all areas will be this part. Okay, this will be the solution of your system. Okay, again, the blue line, the blue area is still continuously go to the right side. Okay, it's not limited there. It's just that, yeah, for the sake of the space. Okay, so let me just give you another example, and I want you to be careful in uh, in in studying these variations. Okay, if this is the case, look, this is greater equals to. It means you can see that this is negative y. It means the opposite. It's supposed to be less than equals to. It means the area below the green one. And then this one, since it is greater equals to and positive, the blue equations you shade the above the line. Okay, this is the below. This is above. But then in this red line, okay, since it is greater than, it means you have to shade or the solution will be the area above the red line. So in the end, if this is your system, we have no intersections of all three inequalities. So intersection must be involving all, not just two, not just one, all. Since we have no intersections of all inequalities, therefore we have no solution. This is another example. Please see the dotted lines and see the direction. Since the negative only the green one, so the green one must be the opposite. It is less than, then it must be above the green line, and then the blue line, since it's less than, it's below the straight line, and the red line, since it is less than, it's below the straight line. Okay, since the coefficient of two equations here, two inequalities of the y will be positive. This is another example. And also this one. This one contains all dotted lines since the inequalities doesn't provide any equal sign there. Okay, so yeah, hopefully you can get the ideas about how to find the solutions of the inequalities. So I have already taught you about how to sheet the area based on the slope intercept form of inequalities or based on the ax plus byc form. Be careful since the you have to be careful with the coefficient of the y. The last part, but not the least, how do we graph it on your paper? Okay, this is the instruction for your homework. So now, if I have, for example, these three inequalities, first you need to graph the line first, okay, the straight line first. Just graph it correctly. Of course, we have this is the green one, the blue one, and the red one. And don't forget, since the red one with this is without equal sign, it means it has to be dotted line. Okay, so now let's sheet it. So the first one, since this is, I don't want to convert this into slope intercept form, so I use the ax plus byc form, but be careful since the coefficient of the y is negative and it is lesser than, it means it has to be the opposite. It must be greater than, above. So it is the area above the green one. So this is how you shade it. This is the first inequalities. And then the second one, go to the blue one. So we have this is y positive, and then less than. It means less than. It is below the line. So shade it there. Okay. And then the last part is the red one. It is greater. Okay. So, and this is positive, the coefficient. So greater means above the line. So yeah, here it is. Okay, so can you see the intersection? Let me just use different color here. Okay, and then I will just erase this. It's just for, yeah, so this is how, what is, so this is how you graph the solution. Okay, and let me show you another example. And actually, the last example, if you are given this system, and the first thing that you need to do is graph the line first. So the green one, the blue line, and the red line. The blue line, since there is no equal sign, you have to put the dotted lines, right? And then let's graph, let's shade it. So the first one, the green one, since it is negative, the coefficient of the y, and it is less than, it means you have to do the opposite, less than, so it is the area above the line. So you can do this actually. Okay, and then from the blue perspective, the blue lines, since it is greater than, it means it must be above the line, like that. So it is like this, and then like that. And then the last one is the red line will be greater than equals to, the y is positive, so it must be like this. So in the end, the intersection of all shades of these three inequalities will be this part. Yeah, I hope that's clear. Okay, yeah. Thank you for watching.